right. Good morning, all. Welcome to another session of Take30 with a Data Advisor. And today we will discuss the best practices in implementing Snowflake. And I'm Dipankar Dasgupta, Senior Consultant with Ironside. And I'm very excited to bring today Jonathan Tao from Snowflake, the company that went public only last week. Very exciting phase in their company. So Jonathan goes by JT, and I'll let him introduce himself before his part of the presentation. And as you can see on the right side, there are a few of these Take30s remaining, and we'll be happy if you can join those as well. All right, so in today's agenda, we have the high level. We are discussing about Snowflake as a cloud data platform, and we'll talk some of the cool features and the best practices that we implement. We have some question Q&A will time at the end, but right now you can also type in your questions as we go along. Before we get into today's topics, I wanted to introduce Ironside. We are in business for 20 years, over 20 years, and we are in the Boston area, but we have clients all over US. And this is our mission statement. We help our clients use data to make better business decisions. So as I mentioned, we have over 20 years experience, mostly in data analytics, predominantly in data warehousing, BI dashboarding and reporting, and data science and machine learning. We do design architecture as well as implementation. We also have managed services, hosting services, as well as one of our newest offering, which is data science as a service, which is called Ascend AI. All right, so these are the topics for today for the Snowflake. JD will cover these topics on Snowflake, which is a cloud data platform. He'll talk about the high-level architecture, elastic compute, and how you can run different workloads without any resource contention with each other. So how Snowflake takes away, we'll also show you how Snowflake takes away the headache of managing your data platform and some of the implementation best practices that we implement. I'll jump in from time to time on the customer use cases and best practices that we implement. And with that, JT, over to you.
Awesome. Thanks, Dipankar. Hi, guys. I'm JT. So I'm a partner sales engineer at Snowflake. I'm glad to be with you today. So before we get in and talk about exactly what Snowflake is, let's kind of set the stage and see sort of what our clients, what you might be looking for, kind of general characteristics for a data stack, a data platform that companies and organizations are looking for today. And really, they can be boiled down into these three, pretty self-evident characteristics, right? They just want a technology that you can make better, quicker business decisions off of, all while reducing the cost of managing that technology, right? Scaling it needs to take less effort, needs to be less costly, and managing it, right? Whether it's from the cost of the tool itself or from human capital being used to manage the system itself, that all needs to be brought down and done in a more reasonable fashion. And of course, at the end, creating a great customer experience with data, and that could be for internal users as well as external users, anyone that might be leveraging any sort of product that you build on top of Snowflake or any sort of customer-facing technology that results from using the platform itself. All right, so how are organizations, and this might look familiar to some of you right now, how are organizations handling it and manipulating data to create this environment, right? Moving data from multiple data sources of all different sizes and shapes, structured, semi-structured, unstructured data, into something that can be consumed by various parties. And really the treatment of data has to move through a bunch of different stages where we've categorized sort of 4 general stages here. And each one of these stages may have multiple different technologies in them. It becomes very complex, costly, and constrained. In data warehousing, you might think we're going to be talking only about data warehousing, but really data warehousing is just a small piece of the puzzle, as you're well familiar. So when we look at Snowflake, right, Snowflake is a true cloud data platform, able to solve, the entire sort of data stack from data source to data consumption, right? So when you think about, okay, well, I thought Snowflake was a data warehouse. Well, yes, it is a cloud data warehouse, but that's really just one of the 6 primary workloads that we set out to become very, proficient at and offer us a unique set of differentiators that allow us to play in each of the spaces, right? So whether that's data engineering and providing a rich tool set and performant way to perform ELT or transformation on Snowflake, whether that's more on data sharing, like the ability to instantaneously and securely exchange and share data in a way that eliminates ETL entirely, right? These type of things are all native to the Snowflake platform. And this is why we're calling Snowflake a cloud data platform, not just a cloud data warehouse. So how do we accomplish that? How does Snowflake make this possible? And if we peel back one layer of the onion, we're going to take a look at the high-level architecture of the Snowflake technology. And starting from the center, the first tier is that core centralized storage, right? The Snowflake managed storage, which is simply going to leverage the object store system of the cloud that Snowflake is deployed on, right? So this is truly, instantaneously scalable, no maintenance on setting size, right? And a single source of truth for your Snowflake account. Next, we have the compute layer, this multi-cluster compute that is completely separated from storage. This is very important because this is a complete differentiation from other data warehousing technologies out there that have tightly coupled compute and storage, these traditional legacy MPP type technologies that use that type of architecture to achieve linear scalability. We are linearly scalable as well, but done in a way where both compute and storage can scale and change size and shape independently from each other. On top of that, you can see each one of these compute slices in the diagram is truly meant to indicate that we can accomplish workload isolation on Snowflake. We can provision independent compute resources that can be assigned to independent workloads in such a way that they do not interfere with the resources of any other jobs being done concurrently. Lastly, we have the compute layer, or the scale-out services layer, the compute cloud services layer, excuse me. And this is really what's going to allow Snowflake to behave like a true enterprise data warehouse in the cloud. And it's also going to allow Snowflake to implement a lot of its near zero maintenance managed service type behaviors in this layer. It's really the brains of Snowflake, as I like to say, that is being orchestrated and implemented in that third tier. And again, like you can see, the foundation of Snowflake is on the public cloud. We are available in 3 major clouds listed below. So, this diagram looks a little complicated, but really the takeaway I want you guys to come away with by looking at this is to see exactly what I mean, what can be accomplished by separate storage and compute and workload isolation on the Snowflake platform. Right, this idea where each cog here is essentially a compute cluster, which we call a virtual warehouse, that's performing a different task, whether it's loading, whether it's doing some DevOps operations, whether it's data science, whether it's maybe a BI tool serving a certain business unit. All of these can be run concurrently without affecting each other on the same copy of data. And then you can see some other sort of unique things that are happening as well, and we're going to talk a little bit about some of these later in the presentation around data cloning and time travel type operations. operations. One thing that I also want you to take away from this diagram is sort of all the logos that are, in the corners of this slide. Snowflake takes a lot of, spends a lot of time and effort, and we take sort of partnering with the tech partners very seriously. It's important that we build sort of rich relationships with other technologies in the space, right? We want to sort of really fit into any data stack that you might be using. And a lot of these partners that you see here have very advanced, rich connectors to Snowflake. And yeah, we definitely encourage you to sort of check out these integrations available and described on our website. Cool.
So I just wanted to highlight JT. So yeah, I like this, even though it's complicated, but I like this slide because it shows Snowflake. It is cloud agnostic, meaning it can be implemented in all the 3 major cloud platforms, and how the workloads can all run independently without any contentions. And I mean, this diagram also like how we are partnering with Snowflake. We also have like several partners in the data integration, BI analytics, and data science space. And we have like implemented Matillion to bring in data from various sources for huge workloads and brought into the Snowflake platform, and then use Tableau and other BI tools like Power BI for their dashboarding. And one of our recent projects that we have implemented, Snowflake is using as a data source, or not as a data platform, bringing in various data sources and building a feature set for a data science initiative. And then we used Python, data robots, and Amazon SageMaker for the AI models. So I just wanted to put out there, like, we are using these technologies which Snowflake partners with as well. Yeah, back to you, Jay.
Great color, Dipankar. Cool. So let me take a short sort of pause and talk a little bit about, the mechanics and how to conceptualize the scale out services, right? So, or the scaling compute, right? So here that you can see, 2 series on this graph. The one in black is specifically showing sort of the runtime of a loading operation, 1 billion records, with using increasing sizes of the virtual warehouse size, right? You can see that we're achieving sort of, at least for the first 4, halving in runtimes, so doubling in performance. The way Snowflake builds is based on the time that these virtual warehouses are online, okay? So, the longer they're online, and dependent on the size, right, the amount of compute that they are inherently is going to dictate the credit consumption for that virtual warehouse. So as you can see, as long as we're doubling in node sizes and we're halving the runtime, right, we're achieving that linear performance, the cost to effectively run this loading operation will stay the same, right? Because you're going to use something that costs twice as much as the previous one, but it's going to run twice as fast. Okay. As you can see, for certain workloads, there is a diminishing amount of returns depending on sort of the scale and the operation you're doing, and that's what we see here by running something that's a little bit too large for what we're doing, and of course, then the cost for doing that, the effective cost goes up. So it's important to know that we have the flexibility and ability to change and provision these virtual warehouses within seconds, so that you can always right size the workload to the right virtual warehouse size. So that previous slide really describes scaling, what I call scaling up for complexity. Snowflake can also scale out for concurrency. So these virtual warehouses can scale in 2 directions, And scaling out is really to help accomplish concurrency, right? To help address high concurrent and high volume workloads. And we're going to see exactly why that's important. So each column represents a different configuration approach for the same spiky workload. The spikiness is represented by this orange sort of stepped graph over time. So the first column is simply allowing these queries to come through a single clustered medium-sized virtual warehouse. I mean, that's fine and good. It's not going to cost you too much money, but as you can see, the response time does balloon in the spiky workload period. And the red sort of part of this column chart indicates queuing time. Okay, so maybe we're going to try to improve on that by increasing the virtual warehouse size, scaling up for complexity. Well, I mean, that's not really the right approach because you're actually paying a lot. You're paying 4 times as much as the medium, yet you're still going to have some queuing in the spiky workload, the highest demand times. Yes, your throughput goes up a little bit. It's not really the right way to accomplish this task. And when you think about comparing Snowflake to other technologies out there that are based completely on capacity, billing 24/7 always online models like Redshift, Azure Synapse, and these type of technologies, Teradata's, right? This is kind of how they work, right? Because you essentially can size and have them on 24/7, and then you would only be able to, do that, maybe once, twice a year for some of these technologies. So Snowflake, the real way to address this, we have this option called multi-cluster warehouses, which will be able to automatically provision identical nodes within the context of that virtual warehouse to address, again, the spiky workloads, address the concurrency, right? So this third option still use the medium virtual warehouse, but allowed up to 4 nodes to be provisioned in parallel to address, the concurrency. And really, it's the best bang for your buck. You get the best of both worlds. You increase the throughput tremendously. You eliminate concurrence queuing issues, and you do it at a cost that's less than extra large, right? Because Snowflake will detect when the demand is coming down, and it will release those extra nodes back into the wild, and then you're not paying for them anymore. So now you're probably wondering to yourself, okay, well, how do I monitor these costs, right? It sounds like there's a lot of flexibility. Costs can come from multiple different virtual warehouses running at the same time. Snowflake does have a best practice of implementing resource monitors on these virtual warehouses. So you're essentially setting a credit quota where you can send certain notifications or perform certain actions to, again, control the credit consumption of these tenants. And Debunker has a couple of things that he'd like to share related to this as well.
Yeah, thanks. So yeah, I mean, this pay-as-you-go models are very beneficial to customers, but sometimes they incur huge bills. And I mean, Snowflake has given us an excellent automated solution in the form of resource monitors, which JT just spoke about. And it's always we always advise our customers as a best practice to implement these resource monitors at the account level or even at the individual warehouse level so that they can monitor at the very granular warehouse how much it is costing them. And because you never know, these kind of runaway queries may eat away all your credits for the month. And these provides notifications, and in extreme cases, it can, as you see, like from the statement above, there are suspend, it can in extreme cases even suspend the warehouses. And we also give our customers some custom scripts as well, besides the automated suspend and resume of the functionality that Snowflake provides off the shelf. So yeah, back to you.
Awesome. So the next couple sections, we're going to talk a little bit about exactly what near zero maintenance means. And what I'm showing on the slide right now are a lot of different operations that you're probably familiar with when running a traditional platform, whether it's managing the infrastructure, whether it's setting up, performance and tuning for performance, the type of data warehouse operations you need to do for that, and anything else around high availability disaster recovery, right? These are all sort of, each one of these phrases or words is associated with something you have to do and time you have to spend on a traditional platform to do that. In Snowflake, we take care of all that for you, whether it's automatics, the way we automatically effectively collect statistics, or the way we provide Snowflake as a managed service, take care of all the upgrading, patching, and things like that. We really want the users to simply focus on loading and querying the data for maximum value. One of the interesting sort of features that kind of fall into this category is this idea of zero copy cloning. And really it's this ability to provision instantaneously and without literally physically copying data, additional working environments like dev or test, right? The way Snowflake accomplishes this is essentially through a pointer management system that's done on behalf of the user. So as you can create additional namespaces across, say, the same database as production, you're going to call it something else. Snowflake is essentially just going to create pointers to the underlying files that we manage in, that represent tables, that represent schemas in this database, and allow you to work on it independently in the context of a dev type database, right? So any type of changes that happen to it will obviously not affect production. The changes in data will only be represented as a delta of the underlying data, right? So inserts will only happen as a delta and impact your storage costs as a delta of the change. Dipankar has a couple of words to say here as well.
Yeah, this zero copy cloning along with like time travel, these features are really cool and lifesavers for developers as well as DBAs. It takes a lot of the headache out. And I've seen like a lot of customers have strict data access to their production environment, and developers, like when they ask for refresh of their production data to the development, they have to go through like days, even weeks. But with the zero copy cloning, you are up and running with a new instance, copy of the production to dev or QA in minutes. And that also does not cost you anything extra. So this is a really cool feature. You can clone like the entire database, maybe a schema or particular tables that you need. So this is a really, really cool feature that Snowflake has come out, and I'm very happy to have used and implemented it in various implementations. Over to you, JT.
Right. Okay, so, in summary, let's kind of go over some of the ongoing considerations for deployment, right? So pretend you start setting up Snowflake. What are the things and tasks that you do want to take care of and do want to focus on? I did say near zero management. I didn't say zero management, right? So role-based access control, right? So implementing a great RBAC model, Snowflake does implement, this type of security system. It's been tried and true, for decades. Next, pairing that with maybe some SCIM access, managing users and groups through Okta or Azure AD. So now you're sort of, getting full control with the nice system for authentication and authorization. Third, we have recently implemented column level security and tokenization within the Snowflake platform. So column level security can be administered via first class masking policy, which you can apply to any PII column in any table and associate access to certain roles in the database. And then lastly, get repository for SQL scripts. While Snowflake is not providing that today, it's a great practice to leverage something like GitHub or version control to control your RBAC scripts, your access, your user creation scripts, right? Your loading scripts, these type of artifacts of your data environment. Over to Dipankar real quick.
Yeah, yep. So, I mean, security, as you know, like it's one of the important considerations for all customers. And I like Snowflake as a company because they take security as one of the top priorities. And like most of the security features are available in all the editions of Snowflake. We do educate our customers to implement like additional security and like in the form of multi-factor authentication, and also give like everything, as you saw, is role-based access. So give the proper level of privileges to each role. And last but not the least, we educate our customers to give like standard naming convention for all the database objects. And it might be not required right now, but important in the future when they might be going for automated solution or scripting, which kind of gives them a pattern if they have a standard naming convention to all the objects. So I think we are almost at the bottom of the hour, but I'll kind of wrap it up. Next slide, please. Yeah, so the key takeaways from this are like how JT said, it's really a cloud data platform, which is truly built for the cloud. And most of other databases that I've seen are kind of built on the legacy technology and just enabled in the cloud. But Snowflake is really different. It's unique and it's simple to implement as well. And JT also already spoke about all these features. And I also mentioned about how we come in and kind of educate our customers and give them the best practices that Snowflake has already laid out and help enable our customers to. And it's a really simple, because of all the headache that it takes away, it makes a real simple landscape for the organizations to manage. So with that, we'll wrap it up and we'll have time for Q&A a little bit. I think that's almost at the bottom of the hour, but I see a couple of questions. So our first question we have here is, can we deploy Snowflake in my VPC?
Yeah, great question.
JT, you want to take that?
Yeah. So Snowflake is available on the 3 major clouds, right? Amazon or AWS, Azure, and GCP, but it's a managed service, right? So there's no way to, deploy Snowflake in your VPC or, bring your own infrastructure and deploy like Snowflake licenses in that way. We have, certain advanced networking, provisions depending on your service level that you sign up for, leveraging private link from the major vendors in efforts to really kind of give that sort of same type of experience from a security standpoint if that's a requirement.
Okay. We have another question. What is the best practice data model to use in Snowflake?
Yeah, we get this question a lot. People might think, oh, I should use a Snowflake schema because it's called Snowflake. That's not true. The only reason why it's called Snowflake is because our founders like skiing. So, we're data model agnostic. I'm going to run a webinar actually next month on implementing Data Vault. We work great with, 3NF, star schema, Snowflake schema works great. Anything that's not going to do anything silly from a SQL standpoint, right? Product joins are not going to be fast on Snowflake. They're not going to be fast anywhere, right? Cartesian joins are just bad practice. So use your common sense, right? Filter early and often, and your performance will be great, and your cost will be low on Snowflake.
So there is another question. As a team with a small amount of data, 150 gigabyte, and small amount of users, less than 10, what are the selling points for Snowflake for our team?
Sure. You want me to take that? I can take that.
Sure.
I mean, Yeah, we definitely have these type of deployments, right? And I think maybe even the easiest one or the nicest one is sort of the ease of testing this out. Right now you can go to trial.snowflake.com and provision and get access to a Snowflake account, a Snowflake instance. You get it pretty much $400 worth of free credits, in the first 30 days. And a size like that, you're going to be able to benchmark, a good amount of, if not the entire sort of data set on Snowflake. And I think depending on, when I hear small use cases, I also think of, potentially a lot of time, whether it's on the weekends or over the nights, where, consumption or compute is not happening. And in Snowflake, you're not going to pay for consumption or compute, right, if you're not running queries and those virtual warehouses are offline. And that's going to, really start paying dividends compared to any other technology where you're technically paying for it to be online 24/7. But in short, I definitely encourage you to check it out and try it for yourself.
Yeah, I know we are already past the half hour, but we have one last question. JT, will you answer this one? Will the dev and prod pointing to the same data have any implication for running long, complex queries on dev that affect reading and writing to prod?
No, so, it's asset compliance, Snowflake's asset compliant, right? So, if there's like a large, complex, maybe merge or upsert that's you're trying to do on dev, and it's running and it's affecting the underlying files in production, production can still select and access those files. They just won't see the changes until the transaction has been finished and committed, which is pretty standard, industry standard practice. So there should be no performance impact.
All right, thank you, JT. Those were great answers. And we are already past the half hour, so can you slide on to the, yep. So here are our following Take30s. We'll be happy if you can attend those. And thank you for attending this session on Snowflake implementation best practices. And thank you all. Thank you, JT.
Thanks, everyone. Bye.